like we went through the primitive data type. Now let's come to the next part which we are discussing, which is nothing but the non-primitive data type. So we can say some of them are arrays, objects and string. Okay, so mostly what are the differences like between the primitive and non-primitive? It stores the primitive one, it stores the actual values directly, but for the reference one it stores the addresses or references. These are the primitives are simple and single values, but if you go for the reference it can be little bit more complex. And if we take the example of the primitive, it can be integer, boolean or character, but in case of reference type it will be string or arrays or classes. For the primitive type, like we see, we have the fixed size in memory, but for the reference type there is a variable size in memory. Now the question might have come to your mind that if we already have the primitive type, then why should we go for the reference type? What is the need of this reference type? Okay, uh, let's see. Also, before going in detail, I would again request you to just like and subscribe the channel so that it will motivate me to prepare such more videos. Okay, so we see that the primitive and reference one. Now let's see the cause why we need what are the limitations of the primitive type, so that we need a reference to be in place. Now take an example. Suppose we need to store multiple values. Okay, the primitive cannot store multiple values. That means each primitive value can hold only a single value. Okay, so if you see in the left side, we are having the int age, which is equal to 42. Okay, now consider there are around 10 people or 100 people around. So there will be age kind of age 1 which is 21, age 2 will be 32, age 3 will be 42, age 4 will be 18, age 5 equal to 65. So how many variables we are going to declare for the same to store these many number of ages? Okay, so in order to avoid that, we have the reference variable, which is the non-primitive data type, which is the array. Okay, we can store multiple values at a single go. Okay, now this is one of the case. Like in case of the multiple storage, we will opt for the primitive data type. Now related to the cannot group the related data. Okay, so for example, we have a person, okay, or an employee. Okay, so it will be having the name. Okay, it is having the age, the employee will be having the salary. Now we want to store all of them together. Okay, if we go for the variable, I have to go for name only, then age, then salary. Then how can I group them to an employee, right? In that case, we need to create an object or the instance. We need to create a class, and then we need to create the instance. Okay, which will be covering in the future session. So in case of the grouping cases, the primitive data type is not going to help, because we have to store different types of data into a single logical unit. Okay, here in case of the employee, we will be having these three type of data types, okay, which we are storing into single logical unit, which is the employee, and it will have all the three stuff. Okay, now third one will be sharing the change across the variables. Okay, now what do you mean by that? Like if the left side you see int a equal to 5, okay, and the right side you see int b equal to a. Okay, so if we change the value of a equal to 10, okay, b will be staying at 5, because we have declared a equal to 5, which is a separate variable, and this is just another separate variable. Okay, int b, which is storing the value of the a. But when we are changing the value to the a equal to 10, so b will be not aware that a has been changed. Okay, so in that case we will be showing like it will be the like the primitive, it will be not sharing the change across the variables. But in case of the reference type, okay, so if you see the person p1, the p1 refers to a person which is created in the heap that will cover in some time, and the name will be alive. Okay, now I will be creating another person p2 which is just a reference. Remember the word reference, which is be pointing to the p1. Okay, here these are the independent copies, here these are the references. Okay, if I change the name via reference 1, okay, which is nothing but the p1, I will be changing the name p1 dot name equal to ls to p2 dot name. Okay, so both p1 and p2 will be will look the same name. Like if I change to alias to John, right, then both p1 and p2 will look for the same name because they are pointing to the same object. They are just a references, they are just a variable having the address of this person. Okay, now next one, like the built-in behavior. So in the primitive data type, we are not able to perform any kind of operation. Okay, on top of that, okay, like that there are not built-in behavior. For example, if I have defined a non-primitive data type which is the hello world, which is a string here, I need to calculate the length. So I can use the built-in function, the length here, which will be showing 11. Okay, then I can change it to the uppercase, I can change to the print the substring. Okay, so if you see here, like object, okay, right side is a bank account object, so it will be having some data which will be the number or can be the id or can be the balance, and it will be similarly having the behavior. So left side was the string, right side is the object will be having some data member and some methods which are the functions, so which combinedly is the fundamental principle of object oriented programming. So we'll come to know about more about string and object when we start with the class. So but the point of this session is to understand why we need the reference variable. Okay, though we already have the primitive variable, what is the need of that? So we can see like storing multiple values, storing the group related data, storing the change across the variable, then having the built-in behavior, we need the reference variables. Okay, look at the one more scenario, right? So one more real world scenario where the primitive is going to fail or false start and the reference is going to help it. So for example, you are building a student management system. Okay, so in that case, like we see in the case of the employee, in case of the student management system also, the primitive data type alone are not going to help it. Okay, in that case we need to add a reference type because one student will be having one id, the roll number. Okay, a student might be having a string, a student will be having the GPA. Okay, and there can be multiple students. Okay, so what will be doing the primitive data type, that will be defining a class which will be having the id, name and double the GPA. Then we'll be switching to the reference one, which will be creating the student, like student alias equal to new student with id 101, the name alias, then the GPA will be 3.8. Similarly, student Bob. And again, if I need to create a list, that means I want to store n number of students, I need to store it in a array list, which is nothing but another reference variable. Okay, if you see here, right, I am storing here, I have created individual students, now I am storing them into all together into the array list. I keep on adding to them. Okay, so second scenario, you can consider up the library catalog. Okay, where we will be having the book, then each book will be having the title, then author, then pages. Okay, so now in most of the terms, right, you have seen, right, for the primary for the primitive one, we saw that the data which is getting created and getting stored in the stack memory, and for the reference it is going to store in the heap memory. Okay, now in order to understand in a kind of the real world scenario, for example, you have the TV, okay, which is kind of the object in the memory, okay, and remote controls are like the references. So for a particular TV, you can have multiple remotes available, okay, which are the variables controlling the same TV. But if one particular person comes and use, there are say 5 to 6 remotes are there. If the person will be using the remote number 5 and changes from channel number 101 to 202, then everyone watching the TV will be watching the same stuff, okay, the same channel, which is the 202. That means any change in the reference will be visible to everyone, okay, having the pointing to the same object. That we'll see as an example, right? If you see here, like person P1, it is pointed to the person object, then person P2 will be equal to P1. That means if you see the right side person object is my TV, okay, person 1 is the remote number 1, person 2 is equal to person 1. That means this remote number 2 is also pointing to the person object, okay. Now if you modify it, then you will be changing, you will be observing the same behavior, okay. That will see in the next example by writing the code for the same, okay. Now we have been talking about stack memory, then heap memory. The primitives are using the stack memory, the references are using the heap memory. Let's see a real one analogy to understand the concept of the stack memory and heap memory, okay. So the stack memory is kind of your wallet, okay, where you are having the cash, the actual cash, right? Whenever you need to buy something, you have your money right there in your pocket, you can access it immediately. So but there is a limit, right? Like for example, you have certain limit of cash in your wallet and you can spend that much only, okay. But in case of the reference one, in the stack plus heap one, what you will do, you will be having the ATM card, okay, which are not the actual cash, but you can use the ATM card to pull the money from the ATM, and it will be holding much more amount as compared to your wallet. So you can consider this wallet as the stack memory, which is very fast, which is easily accessible, and but the reference one you can consider as a ATM card. Like you can get the money, but you have to use the ATM card for the same, okay. Now you need to see that how the primitives and the non-primitives are getting stored in the memory. If you see here in the stack memory, this is the left side, the left box is my stack memory and the right box is my heap memory, okay. If you see, I have one of the primitive variables which is int age, value equal to 25, that is getting stored in my stack memory, okay. And the second one is the double, which is also getting stored in the stack memory. Then the third one, which is the name, which is the reference, it is just holding the address, but the actual name will be getting created inside the heap memory, okay. Now let's see kind of the action, okay. Let's go to the write some program to see that, okay. So let's declare a primitive variable like int equal to 5, okay. Then I will be creating another primitive variable and I will be assigning it to the class integer a. Now let me print it, okay. So what I will print here, like a value, okay, this will be a, then I'll be putting a space here, then b equal to plus b, okay. So here I'll show This is the A, B equal to plus B. So what is the expectation here? Let's try to run it. You see the A is showing 5 and B equal to 5. This is as expected, right? Now let me do one thing. So let me change A value to the 10. Okay, let's go to the observation here. What we have learned before. You see, the primitive cannot share the changes across variable. Let's observe that. Okay, I have changed A to 10. Okay, now let me put a line just to see what will happen to the next. Let me run it again. Okay, what did you see here? That the value of A has been changed to 10, but value of B remain as it is, because it is kind of the independent copy created in the name of the B. Okay, now I have defined one class. If you see here, this is the class. Okay, this is the employee class. Okay, which is having the name, age and salary. Okay, then I have created one constructor that I will show you. But the purpose of this demo to see the reference primitive and references on action. Let me see here. I will be creating, this is the star mark. Then what I will do, let me create one instance. No need to worry about that. That will be covering later. New employee. The name will be alive. Age will be 29 and salary will be this value. Okay, now what I will do, I will create another employee E2 equal to E1. Okay, let me try to print the E1. Okay, then let me check employee 1. Okay, then I'll print again employee 2. So what happens here, when I create this employee U1, this E1 is created in the stack. Okay, but it will be pointing to the reference that will be created, the instance will be created in the heap memory. You see, person P1 is created here, but the object that will be created in the heap memory. Okay, so like this we have created here, right, employee 1, but it is referring to the heap memory. Okay, now what I will do next, let me try to print it, what it is showing. Okay, you see here it is showing both the data are same. Okay, because they are pointing to the same reference. Now what I will do, I will do a change E1 dot set name to any other name like Bob. Okay, let me try to print again. So you see here both of them, sorry, my bad, let me change it to this. Where you see here both of them are pointing to the Bob, the updated name, because these are the reference. In the first case, when we have the A equal to 5, B equal to 5, those are two independent copies of the primitive data type that are being created. So when I change the value of A to 10, B remains what is assigned to it before. But in case of the employee 1, when we created the employee 1 and employee 2, we have two references created. One is the E1 and E2 pointing to the E1. But any change in the E1, okay, that is being replicated for the E2. So you understood the TV and remote concept that we have been discussing so far. I think you are pretty much clear about the reference data type. So mostly what we did, we created the reference. It is pointing to the heap memory. Okay, mostly we'll be using it to solve our complex program like complex data, the dynamic side, and once we'll be going for the object oriented like with data and behavior associated with that, and for copying the large objects when passing them around. Okay, so this is the visualization. You can see here the employee one, what we have, it pointed to the name, and I can here change. Okay, so these are some key characteristics of the reference data type. So since it is itself it is a broader topic, we will be covering it in the later phases, but just to remember, you can have a look towards this table, right? The default value. Okay, the reference will be having the default value as the null. Then the shared references that we saw in the demo, that both reference will be having the same object. The method access will be allowing to call method on the same object. Okay, then comparison, the double equal to compares references, not the content, that will be going in detail during the string phase. I hope everyone is now clear about the what are the data type. So let's look at the tab, that mind map. Like we have the data type and the primitive, another one the non-primitive, and the primitive which like integral numeric value, then floating, then character, and then logical one. Then further the integers are into byte, float, integer, and long. For the floating point, we see float and double. For the character, we see the char. For the logical, we see the boolean. And for the non-primitive one, we see the string, object, and array. And for the string, we see that it can be text data or object, it can be instance of classes, and the array, the collection of the similar element. So you can keep a note of this mind map so that it can be helpful while preparing for the interview, just to even if writing the program, just to have it in the memory. And thanks again everyone, but please do like and subscribe to the channel.